Hello and welcome to Supplier Soundbytes, S&P Global Mobility's concise Autology podcast series, where we sit down with supplier experts to explore what's really changing in the automotive industry and why it matters. One topic, one clear takeaway, all in under 10 minutes. Today we're looking at how artificial intelligence is reshaping automotive engineering, from the discovery and testing of new materials to the way vehicles are designed, validated and brought to market. I'm delighted to be joined by Isaac Squires, CEO and founder of Polaron. Polaron is an AI startup spun out of Imperial College London that uses generative machine learning to accelerate the design and optimization of advanced materials. Isaac, welcome. It's great to have you with us.
Very nice to be here. Thank you, Matthew.
You're most welcome. So, to get us started, AI is often associated with software, but Polaron is applying it to materials engineering. Where do you see the biggest opportunities for AI in automotive materials development today, would you say?
Well, I think the interesting problem that we see in automotive engineering in general is that it really is a kind of multi-length scale design problem. When we're designing cars, we're actually designing from atoms and crystal structures through structure and components all the way to vehicles and packs. And at each of these layers, you have these very high margin bottlenecks where progress in engineering and science is constrained by something. And that something is normally time to do experiments, time to make and test and analyze data, or compute. Simulations are very costly, very expensive, or fundamentally complexity. The problem itself is very difficult. And what has changed now is that AI can collapse a lot of that work, these things that used to maybe take weeks, months, or sometimes even years, and bring that down to something that we can run through a model, whether that's proposing new atomic crystal structures, accelerating simulations of kind of manufacturing, or extracting information and insights and kind of quantitative data from real world experiments and the like.
That's very interesting. Thank you very much indeed. Automotive companies are under pressure to move faster than ever these days. How can AI help engineers make better material decisions and earlier in the development process, would you say?
So, I mean, materials, obviously, like I mentioned, are one part, but a really fundamental part of how we design vehicles and how we design new systems. And ultimately, materials science and materials engineering today relies very heavily on trial and error and expert interpretation of some pretty complex, messy data, right? And what we've often seen before is this idea that AI is this kind of silver bullet, all answers on all data, and we throw all of our data at it and we hope that the black box tells us something useful, right? But actually, what we've seen is that this isn't always true because the data that we collect and the signals that we measure are as important as the machinery itself. And so what AI is helping teams to do is become genuinely data driven from the start, but we also have to make sure that we're collecting those kind of right signals, quantifying the right behaviors, measuring the impact of changes more thoroughly. And this allows us to surface more kind of mechanistic and understanding of those behaviors. And so once those signals are structured, then we can use AI to find predictive patterns that previously were unseen, unlocking more kind of in silico design capabilities, be able to do more of that inside a computer and less kind of making and testing and that kind of trial and error cycle, which reduces a lot of the kind of later stage surprises and also cuts a lot of the waste and speeds up that kind of iterative cycle.
That's great. It's a very interesting area, actually. And looking ahead just over 3 to 5 years, say, which AI capability do you think will have the biggest impact on vehicle development electrification? Fish out your crystal ball. What you're thinking there?
I think it's an interesting question because we don't know what the next 3 to 5 years looks like with AI. It could be a exponential acceleration of super intelligence, and that's essentially impossible to predict what that might look like. But I think that from my experience and working with engineering customers, I think there's three things that jump out to me about the next kind of big changes. Firstly, this idea that I mentioned earlier about bridging length scales, workflows and combinations of models that can connect behavior across kind of atoms all the way to vehicles to accelerate end-to-end vehicle development programs that not just like the development cycle of a new vehicle but the development cycle of new materials, which often takes decades as well. The second is this idea of kind of closing the loop on processing and simulation. So being able to learn complex relationships between manufacturing, materials, and performance to leave that kind of trial and error behind that we've been doing for the last 150 years since the Industrial Revolution. And then finally, I think this is kind of maybe the most boring part of the answer, but maybe the most actually true, is that it's about enterprise adoption at scale. The full magnitude of the gains from AI only really appear when it's truly embedded inside these companies. As a startup myself, we often underestimate how hard that really is, this kind of large company inertia. But we'll see as that inertia swings, that's when we're going to see the real impact, right? The technology is not going to hold anybody back. It's the ability to adopt that technology and adopt it in a safe, secure, and rapid way that's going to really drive a massive change in the industry.
That's great. Thank you very much indeed. I just wonder, finally, if you could give automotive engineering leaders one piece of advice about adopting AI this year, what would it be? What's top of mind?
So I think that treating AI adoption kind of like an engineering program itself. Engineers are smart, data-driven, kind of value-driven people. And I think looking at where can AI have that kind of high-value impact and being able to kind of lock down what success looks like and what the kind of success pass criteria would be to demonstrate that AI has added value to the company. I think that's one way that especially engineering companies can start to accelerate their adoption. I think, like I also mentioned earlier, this kind of high quality data signals are what AI feeds off. And so investing in the ability to collect that data, but also to be critical of that data and to understand how do we make sure we think about kind of traceability, the quality, the ownership of that data and integration into our workflows. So I think being very kind of investing in setting the groundwork and the foundations for it is super important. And finally, I think this is maybe more of the kind of mentality. It's about being brave. The technology is moving at an unbelievable pace, like crazy pace. And you don't want to wait for a kind of perfect enterprise-wide kind of transformation plan that gets put in over years to make the users, because you'll be left in the dust. And so shipping into real workflows that your engineers, material scientists are using today to be able to learn fast, iterate, and then expand is kind of that's the kind of key to success, I think.
That's very good advice. Thanks very much indeed, Isaac. And that's all we have time for this episode of Supplier Soundbytes from S&P Global Mobility. Thank you very much for listening. If you found this episode useful, please do follow us on LinkedIn for more insights from across the supplier ecosystem. And please do keep an eye out for new episodes coming soon. Bye for now.